Hello, good morning everyone. Today I would like to share with you a topic on a discrete correlation. First of all, what is correlation? Correlation is a measure of similarity between two signals, and it can be solved using the process that is similar to convolution. Correlation also a convolution of one signal with a folded version of the another. And correlation can be denoted or write in the form of Rx hash. This is the cross correlation. X and hash is a cross correlation. R refers to the correlation. So Rs hash refers to the hash n cross correlation with the hash n. Also, you can write as a summation of the xk hash k minus n, or summation of the xk plus n hash k. For the cross correlation of hash x, there is the hash n cross correlation with the xn, or we can write as a summation of the hash k xk minus n, or summation of the hash k plus n xk. And this is the procedure to find the cross correlation. In order to find the Rx hash, the last element of hash n is lined up with the first element of the xn and start shifting the hash n past to the xn. So the pointwise product of the overlapping value are the sum up to generate the correlation. So this is equivalent to perform the convolution of the xn and the folded version of the signal hash minus n. Also, we need to find the starting index of the correlation. That is the sum of the starting index of xn and hash minus n. So similar to the hash R hash x, okay, correlation of the hash n and xn. So the starting index is the sum of the x minus n and the hash n. Just now we talked about the correlation of the x hash and the hash x. But bear in mind that the correlation of the x and hash n is not the same with the hash n xn, because these two are the folded version of each other. That is related to Rx hash n equal to R hash x minus n. Okay, here is the sum of the equation that you need to remember. Rx hash equal to xn cross correlation with the hash n, or we can solve using the Sn convolute with the hash minus n. For the correlation of hash xn, that is the hash n cross correlation with the xn equal to hash n convolute with x minus n. The correlation length is the nx plus n hash equal minus 1, and correlation sum is a summation of xn and hash n. Next, we go to another type of the correlation, that is the autocorrelation. Autocorrelation is the correlation of signal xn with itself, means that x and x, or hash and hash. So same signal, we call it as an autocorrelation. Correlation also an effective method in detecting the signal buried in the noise. Noise is an essential uncorrelated with the signal. Now let's look at the example. Calculate the correlation of the xn and hash n, where the xn is 2504, origin at the value of 5, and hash n is 314, origin at value of 3. Okay, this is the example 2.8. You need to find the cross correlation of the Rx hash. So bear in mind that this is referred to the xn, and this one refer to the hash minus n. So do you still remember? Cross correlation can be solved using the method of convolution tool. So how to solve it? So first of all, you need to flip the second signal, hash minus n. So hash minus n equal to, okay, you flip the hash n, so you get 413. Okay, origin, location of the origin, no change. Second step, what is the starting index of the Rx hash? Okay, if you look at here, the xn, the left hand side you only have 1, and for the hash minus n you have 1 and 2. So total is -3. So -1, -2, -3. So n starting index, n equal to -3. Then what about the ending index? Ending index n equal to, for example, if you look at this one, so you have +1, +2, so 1, 2, 2 only because this one is nothing, so you have 2. So this means that the ends from -3 to 2. So you're using the third step is using the sum by column methods. Using sum by column methods for the convolution. So you draw a table, n from -3 to 2. So the xn is 2504, and then you have the hash minus n, which is equivalent to 413. Okay, using sum by column method, this means that this value will 4 will multiply with this value. So 4 times 2, 8, 4 times 20, 4 times 5, 20, 4 times 0, 0, 4 times 4, 16. And then next you use the 1, 1 times 2, 1, 1 times 5, 5, 1 times 0, 0, 1 times 4, 4. And then next is 3. 3 times 2, 6, 3 times 5, 15, 3 times 0, 0, 3 times 4, 12. Then you sum up. Add 22, 11, 31, 4, and 12. So this will be your Rxh. N equal to add 22, 11, 31, 4, and 12. Then where is origin? Origin, you got to refer to the n equal to 0. Okay? N equal to 0 is 31. The value of 31. So this is your Rxh. Okay, will you get the same answer if your question is Rx? Bear in mind that this is the hash n, and the second one is the x negative n. If that is the case, we're still using the same procedure in which flip the second signal, then you get x negative n, you get 4052. Okay, I rewrite the question. That is the xn is 2504 and the hash n is 314. Now you flip the second signal, that is the x minus n. Here we get 2504, we flip, you get 4052. Okay, and the origin remain the same location, that is 5. Okay, second step, you need to find the starting index. Okay, starting index of the hash n is, okay, left hand side you nothing. For the x minus n you have 1 and 2. So you have starting index is -2. And the ending index for the hash n you have 1, 2, and then for the x negative n you have 1. So you have 1, 2, 3. So n equal to 3. So this means that the index is from -2 to 3. So the third step will be using the sum by column methods. Okay, then you draw a table. N from -2 Okay, so you have the starting index is -2. So your hash n is 314 and the x negative n is 4052. Then you're using sum by column methods. 4 times 3, you get 12. 4 times 1, 4. 4 times 4, 16. And then 0 times everything, you get 0. Then 5 times 3, you get 15. 5 times 1, you get 5. 5 times 4, you get 20. And then 2 times 3, you get 6. 2 times 1, you get 2. 2 times 4, you get 8. Then you sum up. So get 12, 4, 31, 11, 22, and 8. So this one we name it as a R hash X. Then you get 12, 4, 31, 11, 22, and 8. And where is the origin? Origin is at 0. So means that it's at 31. Okay, now let's compare your R hash X. Okay, this one, and compare with the RXH. So, if you notice that actually this value is the filtered version or the folded version of this one. So this is actually explain the statement of Rx hash n equal to R hash x minus n. Now, let me share with you some example on the autocorrelation. Okay, let's the hash n equal to 314 and then find the R hash n. So first of all, again, you flip the second signal. So this one is the hash n, and the second one is the hash minus n. So you flip the hash minus n, then you get 413. Okay, origin at same location. Then number second step, you start the starting index. Okay, starting index. Okay, if you look at here, starting index, you have 1 and 2, so you have -2. And ending index, for n, you have 1 and 2, so you have +2. This means that the n is from -2 to 2. Okay, so your hash n is 314 and hash minus n is 413. Again, you use the sum by column methods. I think I missed out. This one is actually negative. Okay, so this is negative and this is negative. Okay, so I have a negative 12, negative 4, and 16. And this one is 3, 1, negative 4. And this one is 9, 3, and negative 12. So when I sum up, I get negative 12, negative 1. This one I get 26. This one I get negative 1. And this one negative 12. So my R hash is negative 12, negative 1, 26, negative 1, and negative 12. So can you see that this one actually is an even signal? So R hash n is an even symmetric about the origin at n equals 0. So this is the even symmetric. Now I would like to share with you another example. Okay, when the xn or the hash n is not in the numeric sequence. Okay, so given xn equal to a power of n un and a modulus a is less than 1. So find the autocorrelation rxxn. So rxxn equal to summation from negative infinity to infinity xk hash k minus n. This is the formula that you need to remember. So how to solve this one? If you look at this one, xk, xk, this means that if you compare with the xn, the difference is just the one is n, one is k. So if in terms of k, this means the n in the xn should change to k. So now you have the ak, uk. So summation minus infinity to infinity ak, uk. And then hash k minus n, this means that now it's a autocorrelation, which means the hash also the x. So in the x for the hash k minus n, you also using the same source, that is the same xn, but the n should change to k minus n. So now you have a k minus n, u k minus n. Okay, next you can plot these two graphs in order to get the limitation of the graph, limitation of the signal. Okay, you plot the UK. UK means that the signal is from 0 to infinity. Okay, and then you multiply with the UK minus n. This means that the signal is from n to infinity. Okay, when you product these two signals, this means that the signal will be from n to infinity. This is k. Okay, then you will get the signal from n to infinity. So this is the limits of the graph. So now you can, k is from n to infinity, ak minus n. That's the remaining. After you do this one, is the limitation, and then you left a power k, ak minus n. Okay, that is how you get from here. Okay, next I assume that k minus n equal to m equal to 0. So here k equal to m. So k minus n, that is equal to m. So I have k minus n, ak a k minus n. So I will have a k minus n that is equal to m equal to 0. And then I want to change the k in terms of m. Now I have k equal to m plus n. So a m plus n, a m. Alright, so a power of n actually is a constant, so I can take out the a power of n, and then I remain a power of m, a power of m. So a power of m multiplied with a power of m, that is a power of 2m. And I assume a power of 2 equal to alpha, so that I can fix the from the sequence table. So this is the sequence and series. So we will use this one, alpha k equal to 1 minus alpha. Okay, we will use this formula, sequence and series formula. So from table, we get a power of n 1 minus a squared. Okay, so this one from table, I will write it here, a power of n 1 minus a squared. That's all. Okay, do you understand? So this is the auto correlation example. Now I will share with you another one in the cross correlation. Okay. Let the xn equal to, so this is new example, right? Xn equal to 0.5 power of n un, and hash n equal to 0.4 n un. So compute the cross correlation. So this means Rxhn. Okay, so Rxhn equal to the summation of the xk and hash k minus n. So again, for the xk, all the n in the xn will change to k. Okay, so 0.5k uk. For the hash k minus n, all the n in the hash n will change to n k minus n. Also this one, uk minus n. So now 0.5. Okay, so summation minus infinity to infinity, 0.5k uk, 0.4k minus n uk minus n. Okay, now I use this tool to plot the graph to get the limits. This is uk, which is like this to infinity, and this is uk minus n to infinity. So is these two product, or what will you get? So this one is from 0 to infinity, and this graph is from n to infinity. So when these two graph product means multiply, you will only get the limits from n to infinity. Okay. you will get the summation k go to n to infinity. Now will remain 0.5k and 0.4k minus n. So 0.5k and 0.4k minus n. So this is equivalent to, you assume k minus n equal to m equal to 0. Alright. So this one, I assume that one is m equal to 0 to infinity. So this one 0.5. So k is referred to m plus n. So now 0.5 m plus n, 0.4 m. Okay, this is equivalent to 0.5 times with 0.4, you get 0.2. So the product of this one and this one, for power of m, you will get 0.2. So the summation m equal to 0 to infinity, 0.2 m, 0.5 power of n. And this, when this one you refer to the series and sequence table, you will get 1 over 1 minus 0.2 and then time with the 0.5 power, and this is just a constant. So at the end, 1 over 1 minus 0.2, you get 1.25 and then time with 0.5 n un. So that's all for the cross correlation. Hope you can understand and enjoy the YouTube video. Thank you for watching.